Hello, let's look at velocity time graphs. A velocity time graph displays the motion of an object with time on the horizontal axis and the velocity on the vertical axis. Very similar to other graphs that we've seen. The important thing that we need to remember here is that the slope on a velocity time graph is the acceleration. And what students get confused about is sometimes a velocity time graph looks just the same as a displacement time graph, and therefore their interpretation gets confused. You've got to make the effort to recognize what type of graph you're looking at, because that determines what type of interpretation you can make of the slope and other things on the graph. Now, for a velocity time graph, the displacement of the object is given by the total area lying between the graph of motion and the time axis, and we'll look at that in a little bit more detail. Let's just look at some and see if we can interpret them. Now, these look very similar to the ones we did before, but notice the axis is labeled differently, and that's how we tell what sort of graph we're looking at, by the labels. And you've got a V there for velocity and time here, and this object, recognizing that velocity could be both positive and negative. In this case, the velocity stays at 0, so this object is stationary, it's not moving. What about this object though? It starts off with a velocity that could be 5 meters per second or 10 meters per second, and as time ticks by it stays at that rate. Therefore, this object must be moving at a constant speed. Constant velocity would be better. This case starts with a velocity, and the velocity is changing. It's increasing, because going up this scale is increasing velocity. So this is increasing, and it's increasing at a steady rate because it's a nice smooth straight line. What does that mean? It's accelerating uniformly is what we use the term. So if the rate of acceleration is constant, we call that uniform acceleration. And in this case, the velocity is starting here and it's decreasing with time, and even goes to negative. So this is decelerating uniformly. So this is a positive slope. This would be referred to as a negative slope, and as we learnt before, if you have a negative acceleration, that's decelerating or slowing down. Now here's an interesting bonus question. What's happening just there? Interesting. Well, at this point just here, the object has slowed down, slowed down, slowed down, slowed down, slowed down, slowed down, stopped. So at this point here, the object stops only for a very short period of time, because the object then starts moving in the opposite direction. That's what this part of the graph means. So what sort of scenario would that be? Well, that would be, imagine you're driving along, you put on the brakes, you slow down, you stop, you put it in reverse, and you start reversing. That's what this graph is describing. Bit tricky. We'll get lots more of those in the future. Now, how do you tell the displacement on a velocity time graph? Well, as we said before, it's the total area lying between the graph of motion and the time axis. So here's our graph of motion. It's probably not the best axes, so let's actually draw those axes in a bit thicker. One of my girls is barring in the background. So there's our 0 point. Whoops, oh that's terrible. And there's our velocity. There's our axes. Let's make that a little bit thinner. And here's our motion graph. So the object's doing this motion. And we don't need to describe it, we've got no units or anything, but if we were asked to find the displacement for this object, we would work out the area of A, and we add up the area here. So we divide and conquer basically, because it's a funny shape. It's easy to work out this triangle and then this rectangle, and over here we've got this funny shape here, so it's easy to make this rectangle and this triangle. And because we're after the displacement, this is positive displacement. Let's call this, let's go purple. This is positive displacement, and this is what's called negative displacement, in the negative direction. And so the positive displacement minus the negative displacement gives you the total displacement. And here we have it, A plus B minus C plus D. Now why is this negative displacement? Because if this was the object, that's its starting position, and what this is describing is it's going faster, 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 then travelling at constant velocity, then stopping. So it travels faster, 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 constant velocity, then stops for a period of time, and then because we're now in the negative velocity area, whereas this is positive velocities, the object now starts moving back like this at a constant velocity, and then slows down and then stops. And so A and B is actually this distance from there to there, and C and D is describing this distance from there to there. But because we went from there to there, it's a negative displacement, and because we went from here to here, A and B is a positive, and that's why we subtract this displacement here. Okay, so whenever we have an area below the zero line, that's a negative displacement on a velocity time graph. Pretty confusing, but when you get to do a couple of questions, it should make some sense to you. And we'll do a couple of examples later on as well. Now, what's happening? Now, the distance of an object is given by the total area lying between the motion graph and the time axis, irrespective of whether it's positive or negative. And so, because displacement, whoops, let's go back. Because when we did this, because the object went from here to there and then to there, this is A plus B and this is C plus D. Because we're only after the distance, that's the complete length of that blue line, in which case it's the area, this area plus this area, so A plus B plus C plus D. But remember, that's the working out for distance. If we jump back a slide, if I can, remembering this is the working out for displacement, positive distance, negative distance. Right. In the next video, we'll actually look at acceleration time graphs. See ya.